Scarab Jew, also known as Insect Jew, is a red supergiant star that would reach the orbit of Jupiter if placed where the Sun is, making it enormous and incredibly unstable, on the brink of a massive explosion. Such stars emit colossal amounts of energy, surpassing that of 1 billion suns. This immense power makes stars like Insect Jew some of the universe's brightest sources of radio waves. When we think of stars, we often imagine tiny, twinkling lights in the night sky. But in reality, stars are far more dynamic and complex. One of the largest, Betelgeuse, stands out due to its size and mysterious behavior. For years, scientists have studied it with fascination, but recent developments regarding its potential explosion have raised new concerns. Join us as we delve into the latest findings on Betelgeuse's possible destruction as observed by the James Webb Space Telescope, and explore what this could mean for our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a truly awe-inspiring star, a giant that has captivated astronomers for centuries. Ancient Greek astronomers, including Ptolemy, were among the first to record this star. It's so vast and bright that it can be seen from Earth, especially during winter. Those familiar with constellations may know Betelgeuse as the reddish-orange star marking the upper left shoulder of Orion. This ancient star is one of the brightest in the night sky, but its brightness varies, one of its most fascinating traits. The majority of stars we see are extremely far from Earth, with the closest being Proxima Centauri, located 4.2 light-years away. To put it in perspective, if you could travel at light speed, it would take 4.2 years to reach this nearest star. Light travels at approximately 186,000 miles per second, covering vast distances, about 5.88 trillion miles in 1 light-year. With these enormous distances in mind, it's remarkable that a star like Betelgeuse, over 600 light-years away, shines so brightly in our night sky. Its visibility despite the distance can be attributed to its immense size and luminosity. Betelgeuse is around 500 times the Sun's diameter and has an estimated radius over 1,000 times larger. Its mass is thought to be between 12 and 19 times that of the Sun, though precise measurements are challenging since it lacks surrounding planets for easy comparison. Nevertheless, scientists believe Betelgeuse is at least 15 times as massive as the Sun. Its brightness fluctuates from magnitude +0.0 to +1.6, meaning it's nearly 100,000 times more luminous than our Sun, which is why it's classified as a red supergiant. Betelgeuse's fluctuating brightness is due to pulsations, periods of expansion and contraction, that can last from days to over a year. During expansion, it shines brighter, and as it contracts, its light dims. Another fascinating feature of Betelgeuse is its dark magnetic spots. These spots have magnetic fields far stronger than the star's average surface, and they inhibit hot gas from reaching the surface, resulting in cooler regions. The Sun also has magnetic spots, but Betelgeuse's are larger and more numerous, some twice the size of Earth. Its magnetic field is about 50 times stronger than that of the Sun, causing gases on its surface to appear as loops and arcs. Betelgeuse's surface temperature is around 3,500 K, cooler than the Sun, giving it its deep red hue. Interestingly, it wasn't always this color. About 1 million years ago, Betelgeuse was more yellowish like the Sun. Over the centuries, it has gradually transformed into the red supergiant we observe today, indicating its advanced age. Betelgeuse emits nearly 100,000 times more energy than the Sun, and if it were closer, it could rival the Sun in brightness, visible even in daylight. At 600 light-years away, it's visible to the naked eye, a testament to its sheer size and luminosity. Were Betelgeuse closer, it would outshine many celestial objects, and if it replaced our Sun, its vast size would engulf the orbits of Earth and the inner planets. In summary, Betelgeuse, or Scarab Jew, is a remarkable star whose size, brightness, and volatility make it a subject of intense scientific interest. Its potential supernova, as anticipated by the James Webb Space Telescope, could have far-reaching effects on our galaxy and offers a rare chance to witness the end of a supergiant's life cycle. The thick outer layers of the star provide insights into the critical role Betelgeuse plays in stellar evolution studies. Research on Betelgeuse, a massive and relatively close star, helps scientists understand stellar life cycles and the processes that ultimately lead to a star's end. Observing Betelgeuse's brightness variations and complex atmospheric phenomena allows astronomers to refine models of stellar evolution, particularly the late stages of a star's life, and the events that trigger dramatic end-of-life stages. Betelgeuse's influence extends to its surroundings as one of the brightest stars in our galaxy. Its intense radiation and stellar winds impact the interstellar medium nearby, potentially fostering new star formation by compressing surrounding gas and dust. When Betelgeuse eventually explodes as a supernova, it will release heavy elements into space, enriching the interstellar medium and contributing to the formation of new stars and planetary systems. Historically, Betelgeuse has held cultural significance across civilizations. Its prominent position in the Orion constellation made it an important reference in ancient mythology and navigation. Its striking red color made it an easily identifiable target for early astronomers. Betelgeuse's cultural relevance continues today as it remains a subject of interest in both scientific and popular contexts. The future of Betelgeuse research is promising, with upcoming missions and studies, especially with the James Webb Space Telescope's advanced infrared capabilities, expected to provide unprecedented views of Betelgeuse and other distant stars. Researchers are eager to observe Betelgeuse's final evolutionary stages and capture the moment of its supernova explosion. These future space missions and observatories will continue monitoring Betelgeuse, offering valuable data to enhance our understanding of massive stars and their role in the universe. Although Betelgeuse itself has no known exoplanets, studying such massive stars can shed light on the formation and evolution of planetary systems around similar stars. Understanding the conditions that lead to exoplanet formation around massive stars can help scientists compare with planetary systems around smaller, less luminous stars like our Sun. Research on Betelgeuse and similar stars contributes to the broader field of exoplanetary science, helping us grasp the diversity and potential habitability of planets across the galaxy. Betelgeuse's prominence in the night sky and its fascinating characteristics make it an excellent subject for public engagement and education. Astronomy outreach programs often use Betelgeuse to illustrate key concepts in stellar physics and star life cycles. Public talks, planetarium shows, and educational materials frequently feature Betelgeuse, inspiring curiosity and interest in astronomy. By highlighting the significance of stars like Betelgeuse, educators can foster a deeper appreciation for the complexities of the universe and the role of scientific inquiry in uncovering its mysteries. In popular culture, Betelgeuse has also left its mark, most notably through its name's use in films, books, and other media. The star's name was famously used as the title for the 1988 comedy-fantasy film Betelgeuse, directed by Tim Burton. Although the character in the film is not related to the actual star, the name association has brought additional attention to Betelgeuse, sparking interest in its astronomical significance. Popular culture references continue to emphasize the star's importance and contribute to the public's fascination with astronomy. On a larger scale, the study of Betelgeuse has broad implications for our understanding of the universe. By examining such a massive and distant star, scientists gain insights into the fundamental processes governing stellar evolution and galaxy dynamics. Betelgeuse serves as a cosmic laboratory for studying the limits of stellar behavior and the impacts of massive stars on their surroundings. The knowledge gained from studying Betelgeuse will deepen our understanding of the universe and help answer fundamental questions about the nature of stars and their role in the vast cosmic tapestry. Betelgeuse, also known as Betelgeuse, is a massive star located about 600 light-years from Earth in the constellation Orion. Renowned for its immense size and brightness, Betelgeuse emits more radiation than our Sun and, in terms of radius, is around 1,000 times larger. If positioned at the center of our solar system, it would encompass the orbit of Jupiter, highlighting its truly colossal scale. Unlike most stars, Betelgeuse doesn't appear merely as a point of light through powerful telescopes but as a distinct disk. Despite its vast size, Betelgeuse is not the most massive star, with an estimated mass ranging between 12 and 20 times that of the Sun. This variation in mass estimation stems from the challenges of accurately measuring stars without a companion to provide gravitational reference points. Even at the lower end of this estimate, Betelgeuse remains an astronomically significant star. Betelgeuse's brightness is another of its defining characteristics, fluctuating over time from magnitude 0 to plus 1.6. A magnitude 0 star is about 2.5 times brighter than a magnitude 1 star. At its peak, Betelgeuse can shine nearly 100,000 times brighter than the Sun, thanks to periodic pulsations that cause it to expand and contract. When it expands, Betelgeuse grows brighter. When it contracts, it dims. These pulsations, which result from internal processes, can last from days to months, giving Betelgeuse a dynamic and shifting appearance. The star's surface temperature, approximately 3,500 Kelvin, is relatively low for a star of its size, giving it a distinctive reddish-orange hue typical of red supergiants nearing the end of their life cycle. Like other red supergiants, Betelgeuse has exhausted the hydrogen fuel in its core and has started fusing heavier elements. This fusion process generates energy that causes the star to expand outward, forming a complex outer atmosphere filled with magnetic spots significantly larger and more numerous than those found on the Sun. These spots, regions of intense magnetic activity, prevent hot gases from rising to the surface, resulting in cooler areas across the star's surface. Betelgeuse holds a prominent place in both science and history. It has been observed and recorded by various civilizations for centuries, its distinct winter visibility in the northern hemisphere making it a notable feature in mythology and stargazing traditions. Scientific attention to Betelgeuse surged in recent years following its unusual dimming events between late 2019 and early 2021, during which its brightness dropped significantly, leading to speculation about an imminent supernova. However, further observations suggested that the dimming likely resulted from a combination of material ejections and dust clouds obscuring its light. As a red supergiant, Betelgeuse is in an advanced stage of stellar evolution. Stars in this phase begin fusing elements like helium, carbon, and oxygen after exhausting their hydrogen. This process causes the star to expand, shedding outer layers that may eventually form a planetary nebula, while the core might collapse into a neutron star or black hole, depending on its final mass. Betelgeuse's eventual supernova will be an extraordinary astronomical event visible from Earth, even during the daytime. However, observing Betelgeuse in detail poses challenges due to its sheer size and brightness, which can obscure finer details. To address these difficulties, astronomers employ advanced observational techniques like interferometry, which combines data from multiple telescopes to create higher-resolution images. Space telescopes, including the Hubble and James Webb, play a crucial role in observing Betelgeuse across various wavelengths, including infrared, which penetrates dust clouds that otherwise obscure visible light.